we're going to talk about what makes up density, what does density mean, how can we change density, and so, well, let's get started. So density involves the mass of an object. And well, what is mass? Well, mass is the measurement of the amount of matter or stuff in that object. We tend to measure mass in grams, and there are 4 different states of matter. We have solids, liquids, gases, and plasma. Plasma is one of the states of matter we're not going to focus a lot on this year, but it is basically, if you think about lightning is an example of plasma. It's more of the flow of energy and electrons. So we'll talk more about that if you would like when we get into the classroom, but at the moment, just know that it's there, but we're not necessarily going to talk about it. So we also have volume. So volume is the measurement of the amount of space an object takes up. So we can actually do volume in 2 different ways. We can actually measure in milliliters, and we can do that by having a water displacement. And we typically do this for things that are odd shaped, like rocks, people, whatever. If it's an object that has an easy to measure shape, like a cylinder or a rectangle, then we're going to use the actual volume formula that we get like when we have a geometry class. So for an example with a rectangular object, it's going to be length times width times height. Here's an example of how to calculate it. So that's volume. And I don't remember saying this earlier, but I would highly recommend that you write some notes as we go through. So if you need to stop this for a second to go grab some paper, you can go back and rewatch what mass definition is, but here's the volume definition, because you will need these as we move forward. So here's a question for you. What do you think would have the greater volume? Do you think it's going to be the kilogram of feathers or the kilogram of bricks? And I'm hoping that you said the feathers would have a greater volume. So which one do you think has a greater mass? Well, they have equal mass. They're both a kilogram. The difference is, since the feathers are so much lighter, you need a lot more of them to get to that mass. So density, well, what's the definition? Well, density is defined as the mass per unit volume. It measures how tightly packed or how heavy the molecules are in an object. So density is the amount of matter within a certain volume. And so looking at these pictures here, you can see that the one on the left has the same volume as the one on the right, but there's a lot more stuff in it. So therefore, it would be considered denser. So now here, if each dot was to represent a person and the circle represented a room, which circle has the highest density of people? Would it be A? Would it be B? Maybe C? Maybe even D? Hopefully you selected B because there's a lot more people in that room than the others, so therefore it has the highest density. Which circle do you think has the lowest density? Hopefully you selected D because D has the least number of people in the same size room as the others. So now the same scenario, the dots are people and the circles are our rooms. Which one is more dense? Is it A, B, or C? Hopefully you picked A because A has a lot of people, same number of people as room C, but the difference is there's a much smaller space, so therefore it is more dense. So now we're going to figure out, how do we actually find the density of an object? In order to find the density, we need to find the mass of the object, and we would use a scale or a balance to do so. Then we need to find the volume of the object. For this, we're either going to use a ruler and measure the length, width, height, or we're going to use water displacement. And then from there, we'll take those 2 numbers and we'll divide. So the formula is density is mass divided by volume. So I'm going to get the mass by using my balance. I'll get the volume by either calculating it and using a ruler or by using water displacement, where I look at how much the water level changes from when the object is not in the water to when the object is in the water. So we're going to do some practice. So if the mass of a cube is 35 grams and it takes up 7 cubic centimeters of space, what is the density of the cube? First thing we need to do is we need to figure out what information is provided in our story problem. We know that the mass is 35 grams, and we know that it takes up 7 cubic centimeters of space. So I know my mass and I know my volume. So here I know mass and I know volume. So what do I do with this information? I set it up in my equation to where my density is going to equal my mass divided by my volume. So we plug in our calculator, 35 divided by 7, and we get an answer of 5 grams per cubic centimeter. So you'll notice that the units are mass per volume. And so when you give me a unit that has mass per volume, I know you're talking density. So the units are going to be important when you answer any of these questions. So let's practice again. So Frankie has a paper clip with a mass of 9 grams and a volume of 3 milliliters. What is the density of the paper clip? So what do we need to do first? We need to find out, well, what do we know and what do we need to find out? I know the mass is 9 grams and I know the volume is 3 milliliters, but I don't know density. So now I have to think, do I have enough information to solve for density? Well, here's your formula. And I know mass and I know volume. So what do? I plug it in my equation. So density is 9 grams divided by 3 milliliters. And when I take 9 divided by 3, I get an answer of 3 grams per milliliter. So one more practice. Jack has a rock with a mass of 6 grams and a volume of 2 milliliters. What is the density of the rock? Well, I don't know density, but I know what the mass is. I know what the volume is. So I take my mass and my volume. So my mass is on top, volume is underneath. So 6 divided by 2 gives me 3. Alrighty, your turn. Lisa wants to know the density of her shoe. No, I don't know why she wants to know this, but all the power to her. She finds the mass of her shoe to be 2,200 grams and the volume is 450 milliliters. What is the density of Lisa's shoe? Well, we pull out our information. We don't know density, but we do know the mass is 2,200 grams and we know the volume is 450 milliliters. So I plug it into my formula here. So mass is on top divided by my milliliters. So 2,200 divided by 450, I get 4.9 grams per milliliter. That is the density of her shoe. So now there's different ways density can be affected. So you can change the mass and keep the volume the same. So in my pictures, you will notice the boxes are the same size. Now, if I increase the mass, in other words, I'm adding more of my little smiley faces, my density is going to increase. So going from A to B, my density increased. But if I decrease my mass, so therefore I'm going from B to A, you'll notice that my density has decreased because now the same volume, the only difference is the number of little happy faces inside. Other ways density is affected is what if you change the volume but keep the mass the same? So here A and B have the same number of suns, but the difference is their size. So if I increase my volume, so I'm going from letter B to letter A, what happens to the density? Well, it gets less. Now, what if I am Now I'm going to decrease my volume. So I'm going from A to B. You'll notice that my density is increasing because I have the same number of stars or suns, but the space is much smaller. So a quick review. What are two ways to increase density? So here's my little box, and I have 5 hearts in it. What's one way I can make the density larger? And what's a way I can make my density smaller? Hopefully you said that you can change, keep the mass the same, but decrease the volume. Or you can have the same volume, but increase the mass. So those are the ways we can increase my density from here. I can make it smaller, I keep the number of hearts the same, or I keep the same size, but add more hearts. So final question. What is the formula for density?